Problem number 9. In the laboratory, 3 different solutions of the same salt were prepared. The first beaker contained 200 grams of water and 5 grams of solute. The second beaker contained 500 cubic centimeter of 10% by mass of aqueous solution of salt with a density of D equals 1.04 gram per cubic centimeter. In the third beaker, 150 grams of an aqueous solution of salt with a concentration of 5% by mass was prepared. Then, all 3 solutions were poured into one glass dish and its contents were mixed thoroughly. What is the percentage concentration by mass of the new solution obtained by mixing all 3 solutions together? How to take a stab at it? How to go about this problem? We have so much data, but in the end, we don't really know where to start. Guys, let's not panic. This is actually an extensive problem and it will not appear on a regular quiz, but it may appear on the exam. The good news is that if you are able to solve this type of problem, you will be able to solve any problem involving the calculation of the percentage concentration by mass of a solution. Before we even write out the data, we will draw the beakers to sort out all the information we have here. The point is to write everything we know from the given problem correctly, emphasis on correctly, before we even start solving them. This drawing can replace writing down the data, but for the sake of formality, let's also write down the data. Oof, we got it. This is a problem where even the data is difficult to write out, so it's such a turbo problem. Guys, don't be afraid. Despite its looks, it is not a difficult problem, and the most important, you don't have to memorize anything to solve it. So, how to go about this problem? As we know, the percentage concentration by mass is the number of grams of the solute in 100 grams of solution. In the task, we need to calculate the percentage concentration by mass of final solution that will be obtained by mixed 3 over solutions. So to calculate percentage concentration of final solution, we have to find mass of each solution and mass of solute contained in every solution. Because we have some counting to do and I have limited space on this board, I suggest making a chart into which we will successively enter what we calculate. The chart, guys, will help us not get lost in the calculation and will be easier to see what we already have and what we still need to calculate. So in our chart, four solutions. First solution, second solution, third, and final. So fourth solution. Mass of solution. And mass of solute. So let's start. First solution. In the first solution, we have 200 grams of solvent and 5 grams of solute. So mass of solution 1 equals mass of solute plus mass of solvent, in our case water. So is 5 grams plus 200 grams equals 205 grams. So let's write it into the chart. Mass of solution 1, 205 grams. Mass of solute in first solution, 5 grams. Now, second solution. In the second solution, we have a volume, but we need its mass. I remind you from previous problem how to go from volume to mass. Just look at the density. Density unit. For example, gram per cubic centimeter. Gram, so mass. Centimeter, cubic centimeter, so volume. So D equals M per V. So now we know, after transform this formula, that M, mass of solution, equals D times V. M equals D times V. So mass of solution 2 equals, so M2 is D2 and V2. So mass of solution equals 10.4 gram per cubic centimeter times 500 cubic centimeter equals 520 grams of solution 2. So now we know mass of solution 2, 520 grams. We need mass of solute in the second solution. So in 100 grams of solution 2, there is 10 grams of solute. So, why? Because percentage concentration by mass is the number of grams of the solute in the 100 grams of solution. So if our PCM is 10% by mass, so in 100 grams of solution, there is 10 grams of solute. So mass of our solution, 520 grams, solution 2. There is X grams of solute 2. How to calculate X? By cross multiplying this proportion. So 100 grams times X equals 520 grams times 10 grams. So to solve for X, let's divide both sides by 100 grams. So X equals 520 grams times 10 grams over 100 grams equals 52 grams of solute 2. So, of course, data for the chart, 52 grams. Now, third solution. So we know the mass of this solution, solution number 3, equals 150 grams. We need to calculate mass of solute 3. So in 100 grams of solution 3, there is 5 grams of solute free. So in 150 grams of solution free, there is X gram of solute free. So X equals 150 grams times 5 grams over 100 grams equals 7.5 grams of solute free. 7.5 grams. Now it's time for solution number 4, final solution. Both the mass of the fourth solution and the amount of solute contained in this solution will be the sum of all three solutions. Well, let's calculate to be correct. Let's write it down for formality. So, fourth solution, solution number 4, mass of solution 4 equals mass of solution 1 plus mass of solution 2 plus mass of solution 3 equals 205 grams plus 520 grams plus 150 grams equals 875 grams. This is mass of solution 4, so 875 grams. Now, mass of solute 4. So mass of solute in final solution equals mass of solute 1 plus mass of solute 2 plus mass of solute 3 equals 5 grams plus 52 grams plus 7.5 grams equals 64.5 grams. 64.5 grams. So our chart now is complete. We are ready to make the final calculation. It was not as scary as it initially seemed, was it? Now you just have to decide for yourself whether you want to calculate the final percentage concentration by mass based on proportion or formula. Let's do it in 2 ways. Okay, first way, proportion. In 875 grams of solution 4, there is 64.5 grams of solute 4. So in 100 grams of solute 4, solution 4, there is X grams of solute 4. Once again, why 100 grams of solution? Because percentage concentration by mass is the number of grams of the solute in 100 grams of solution. So X equals 100 grams times 64.5 grams over 875 grams equals 7.5 4 grams of solute 4. These are 7.4 grams of solute is in 100 grams of solution. So it means that our solution is 7.4% by mass. And that's answer for this problem. Now, second way formula. Percentage concentration by mass, final solution, so percent mass over mass equals mass of solute 4 over mass of solution 4 multiplied by 100%. So 64.5 grams over 875 grams multiplied by 100% equals 7.4%. The answer for this problem is of course the same. The percentage concentration by mass of the resulting solution is 7.4% by mass. As you can see, this problem was not as terrible as it seems in the beginning. I spent more time discussing it than solving it. This an overview on how to approach this type of problem, in my opinion, is very important because many students, after reading content, give up. It's a pity because such a turbo problem has a lot of points. Remember, the most important things is to understand the content of problem, because if we know what is it about, we know what and how to calculate it, and that is already half of the success. Finally, I encourage you to solve a few problems on your own. The answer to these problems can be found under the video description. Here are the problems for those interested. Test yourself, test your power. Guys, that's all for today. Thank you very much for your attention. If you like this video, please leave a thumbs up and subscribe to be notified about the next videos. I also invite you to leave comments. Did you like this lesson? Would you like more theory or less problems? Or maybe just the opposite? Maybe you have your own suggestions for further topics. Guys, the next video we will take care about another subject. So thank you so much. Thank you very much for your attention, and see you in the next video of Chemistry without Cramming, a Bowl of Chemical Knowledge.